It's possible to use matrix algebra to solve linear systems of equations. We'll show you how in a moment, but first of all, let me take a look at three matrices, A, X, and B. And let's notice what the equation, the matrix equation, AX equals B, stands for by multiplying this out. Now, AX is 5, -3, 7, -4. Right? X is XY, it's the 2 by 1. And if I multiply this, I get 5x minus 3y, and I get 7x minus 4y. Right? I get this 2 by 1 matrix. And that matrix equals B. 5, 6. Now, you know that two matrices are only equal if they have the same dimensions, they're both 2 by 1, and they both have the same exact equal entries. So 5x minus 3y has to equal 5, and 7x minus 4y has to equal 6. So let me just write that down. 5x minus 3y equals 5, 7x minus 4y equals 6. Now, this system is a system of linear equations. This linear system is completely equivalent to the matrix equation AX equals B, and this suggests a way that we can use matrix equations to solve linear systems. So let's focus on solving this linear system. Now first, when you're turning a linear system into a matrix equation, let's make the observation that on the left-hand side, you want your x and y terms, and you want them in that order. So these are, these numbers here are called coefficients, and what you want to do is you want to come up with the coefficient matrix for the system. And that's going to be 5, -3, 7, -4. That's matrix A. And then the variable matrix xy, that's this. And then the constant matrix 5, 6 is matrix B. Now, how do we solve a matrix equation AX equals B? Well, it turns out that this is basically like a linear equation with real numbers. The only difference is that we can't divide by matrices. There's no way to divide by matrices, but you can multiply by its inverse. So if matrix A has an inverse, you can multiply by the inverse. And remember, when you multiply both sides by a matrix, you've got to multiply either both sides on the left or both sides on the right, because matrix multiplication is not commutative. Well, what are you going to get here? A inverse times A is the identity matrix times X. And the identity matrix times X is going to be X. So this is X equals A inverse B. That's actually your solution. You'll have X, Y equals and then some numbers. So all you have to do is find out what the inverse matrix of A is. Now let's say that we know that A inverse is -4, 3, -7, 5. Okay, say that we've solved for the inverse matrix and we found this. Then X is going to equal A inverse B, which is this, -4, 3, -7, 5, times B, which is 5, 6. And let's just do that multiplication. It's -20 plus 18, -2. -35 plus 30, -5. Right? And this is xy. So that gives us our solution. X equals -2, y equals -5. That's it. So when you're solving a linear system using matrices, the first step is to write a matrix equation like this. Right? You'll have AX equals B. And the second step is just find the inverse of matrix A, the coefficient matrix. Then the third step is to multiply that inverse matrix by the constant matrix B, this guy. All right? Multiply on the left, and you'll get your solutions. It's as easy as that. So it's very important to know how to invert matrices to do this to use this process, but you'll find that it's a very quick process if you're good at inverting matrices.